Welcome to the Agronomy and Farm Management Podcast. I'm Amanda.
And I'm Elizabeth. Thanks for joining us today.
Welcome back to the Agronomy and Farm Management Podcast. Here we are in April and looking towards planting, hopefully in the next couple of weeks. So one of the driving factors of planting success is weather, as we're well aware, and how it affects soil moisture conditions. Last year, I'm sure we haven't forgotten that we faced some challenges with cold soil temperatures in April, but it turned around pretty quickly for most of the state once we reached May.
Yeah. So today we have Aaron Wilson joining us from the Byrd Polar and Climate Research Center, where he's a research scientist. And if you've been with us from the beginning, he was our very first guest on the podcast when we started last May. And Aaron has really become an asset to us in Extension, working to help us understand weather patterns and how it's affecting agriculture here in Ohio. So Aaron, thank you so much for joining us today.
Thank you for having me back.
Why don't we start with a recap from this winter and where it's left us?
Yeah, so as we had hoped, or one of the things that we hoped going into this winter was the potential for El Nino, which often gives a lot drier weather for the Ohio Valley. Unfortunately, that did not take place until well into February. So what it's really left us with, we had a warmer than average winter overall, and a very wet winter as well. It's our 11th wettest winter on record, going back to about 124 years.
Wow.
We had our 5th wettest February. So certainly similar to where we were coming off our winter last year, we have pretty saturated soils, especially across the southern half to 2/3 of the state, a little drier across the north, and certainly some cold temperatures that have lingered, that lingered throughout March.
Yeah, so this residual soil moisture that we're seeing, is that part of what's contributing to the fact that we're not seeing a quick spring warm-up this year?
Yeah, so typically when you've got those colder temperature, more moisture in the soil, it tends to keep your temperatures a bit on the cooler side. It takes a long while for those to warm up. Once we head into spring and summer, those soil conditions really help drive what our ambient temperatures of the atmosphere are like. So if it's drier, the air tends to warm up much faster than when the soils are wetter, which is what we've seen this year and has really been the trend more often than not over the last decade or so.
Yeah, it certainly seems like it that we've started out pretty wet. So what are we looking at, I guess, here in April, trying to get started planting?
Yeah, so again, we're looking to some large scale signals. One of the things we look at is El Nino. We do have a weak El Nino in place. That's just describing the sea surface temperatures in the tropical Pacific, and they're a little bit warmer than average. And then that has some impacts on large-scale atmospheric circulation. And over Ohio, what that means, generally in winter and early spring, it means drier than average temperatures. So over the last 30 days, we've actually dried out a little bit. We've had drier conditions over the last 30 days, say since the end of February, 1st of March, that we can probably attribute a little bit to that El Nino formation and that development. Heading forward, what we're expecting, though, are plenty of opportunities for frequent rainfall. If you look at the forecast, we've had a fairly wet March, as well. And going into April, certainly our models and the overall circulation pattern is favoring an above average April in terms of precipitation. If you look at the general April, May, and June forecast, so that planting period, we're looking at increased probabilities of above average precipitation during that period. So we still expect this active storm track to maintain its presence here throughout the Ohio Valley.
When we were talking before this, you mentioned an area of California that has just gotten out of drought for the first time since 2011. We're aware of the flooding across the plains. Is the U.S. in general kind of in a more wetter state, or are there some dry areas too?
Yeah, there's still some dry areas. In places out west, California, the Four Corners region, they have been dealing with the multi-year droughts, a good 7-year drought in many of those places. So as I mentioned before, but last week was the first week since December 20th, 2011, that no place in California had an official drought. We've seen the areas of drought shrinking in the Four Corners region, but there's some dry areas still lingering there, parts of the Pacific Northwest, parts of Texas as well. But certainly most locations east of the Continental Divide, the soil moisture anomalies are incredibly high for a lot of areas. Certainly we can just recall the devastation and impacts that Nebraska felt in March. But really anywhere east of the Continental Divide, there's very little drought and really very little area covered by abnormally dry conditions at this time. So overall, I would agree that most of the U.S. is in a bit wetter pattern than we've seen of late.
At least when we're talking about the primary corn and soybean areas.
Certainly, yeah, absolutely.
Yeah, I know we've talked a lot recently about how wet the last decade has been, and I know seeing what's happening in Nebraska has really put that into focus for us, at least for me, seeing the amount of water that they're dealing with and the alluvial deposits and long-term what the impacts of the long-term impacts of that flooding is going to be. But this is really a pattern that we're seeing on a broader scale, this large amount of rain that we're seeing. And I've heard the fun fact thrown around that this has been the wettest 10 years on record, going back quite a while. Could you expand on that a little bit?
Yeah, so there's a couple of ways that we can look at that. If you look at the primary threat that we've seen really over the last couple of decades in the Midwest, it's really been from increasing precipitation and also increasing intense precipitation events. And both of those things have gone hand in hand. So not only has the quantity of precipitation increased, and in many locations across the Midwest and here in Ohio, some 5 to 10% if you compare today to the early part of the 20th century. So we're talking about 3 or 4 more inches per year now than what we saw, say, in 1960, that general time frame. What we've also noticed is that not only has it been, a very wet decade, but really we've had predominantly wet conditions since about the mid-1990s. Of course, we've had a few droughts here and there. Certainly, we can remember the flash drought in 2012, which did have an impact, but it was relatively short-lived. But overall, for the last 2 decades, we've really seen a wetter pattern in general. And along with that have been those larger numbers of intense events. So we're talking 1.5 to 2.5 inch rainfall over a very short period of time. And the number of those events has increased. And of course, that has impacts on soil erosion, on the quantity of water in the fields that are really decreasing, suitable days for field work, for harvesting, for planting, and it's having an impact on farmers throughout the Midwest.
So you mentioned the days suitable for field work, and this is one of those things that makes me so excited that we have you here with us in Extension, Aaron, is you're able to take these weather trends that we're seeing and really bring them into talking about things in agriculture that matter. So could you expand on what those trends you're seeing with the days suitable for field work are?
Yeah, sure. So 2 months in particular have here in Ohio, we've seen a decrease in the suitable field days. Of course, these are reported from NASS on a state level since 1995, and we've seen a strong decrease in both April and October trends. So since 1995, we've lost 5 days in suitable field work days in April and also in October. So what's kind of interesting is because our temperatures are also increasing, we've seen about a 10-day increase in our season length. In other words, between our last frost and our first frost, that's generally increased about 9 or 10 days. But we've lost 10 days for field work based on conditions of the field, persistent wetness that we've seen, and it's really tied, some of the monthly records in terms of minimal field days is really strongly tied to precipitation, especially in April. One of the things I think about is in October, when folks are perhaps trying to apply manure, for instance, and not having many open dates for that. And certainly this past fall and even into the winter is a very good example of just the struggle that many folks are seeing now to empty pits and empty lagoons and things like that, with very few opportunities to spread that resource. So this is just an example of how the trends in precipitation are really reflected in the ability for farmers to do what's necessary with their fields.
Wow, that's really interesting. And as we continue to try to improve water quality in our application of nutrients closer to growing times for those crops, this just adds another wrinkle in it. I mean, we already have enough to do in the spring, and now that we're losing days. So that's, I guess, why we continue to focus on research of when to put those nutrients on the crop. How can we do it to a growing crop? Things like that. So some of that manure research that's been done has really taken off, side dressing corn with manure, and then later season nitrogen application in general. So that's really interesting information. So why don't we talk about maybe summer outlook in general over the next 3 months or so?
Yeah. So if we're thinking about summer, so June, July, and August, obviously here we are in April, so we're projecting a little bit out in time. Like I mentioned earlier, when we deal with summertime conditions, we don't have a lot of large scale drivers like El Nino. We don't typically feel summertime impacts with El Nino. What it can impact is the number of Atlantic hurricanes, for instance. So it can really decrease the amount of Atlantic hurricanes, which could then lead to less tropical moisture into our fall, like we saw last year with the remnants of Tropical Storm Gordon and Hurricane Florence, which both really impacted the southern part of Ohio. So with that being said, what we look toward are more long-term trends. So what we've seen in terms of trends with our summertime, it's really fascinating actually, is that our summers are warming, but they're warming about half as fast as our wintertime. And most of that warming is taking place at night. Actually, if you look at the last 30 years compared with the early part of the 20th century, our daytime highs in summer are actually about 2 to 3 degrees cooler. And the reason is for the same reason we're seeing more intense precipitation events. We've got a lot more water vapor in the atmosphere, and that water vapor basically keeps your daytime highs from getting as high as they normally would, but then it also keeps your overnight temperatures warmer than they would be. So we're seeing a more frequent nights where we're staying at 70 or 75 degrees Fahrenheit. So we expect that general trend to continue this summer, where it will be warmer than average, but probably largely driven by our overnight lows. And of course, the warmer we stay at night, the more energy that the crops are expending. And so that can also have an impact. And certainly we see accelerated growing degree days, for instance. So we expect that to be, to really maintain this summer. As far as precipitation goes, right now we're really relying on some models, forecasting models, to look at the precipitation, and we are hedging toward a wetter than average summer. That's what the models are indicating right now. Although I have to kind of preface that with spring is usually our season of least confidence when we talk about projecting into the future. Spring tends to be a season where our models don't have a little bit more uncertainty associated with them because of the various atmospheric processes that are happening. But right now we're looking at warmer than average summer and wetter than average summer.
And does that mean it'll be higher humidity as well? Are we seeing that trend because of the more moisture?
Yeah, absolutely. So another way of thinking about water vapor is to think about humidity. So we've seen an increasing amount of higher humidity in general that lingers not only in the summer but well into the fall. So we can take October of last year, for instance, where we had tremendously high humidity or water vapor in the atmosphere, really keeping our overnight lows in October pretty high. And I know a lot of folks were still dealing with a lot of crop moisture even into harvest season. So that's another impact of the long-term changes that we've seen in our climate.
Well, and it certainly impacts our disease prevalence as well, as a lot of those diseases prefer those moist conditions.
Yeah, so when you're thinking about disease or even insects and weed pressure, I mean, all of these things are really thriving in the conditions that are more prevalent here in Ohio today. So even for things like, the Asian tiger mosquito, not brought here by climate change, but its eggs are surviving our winter as we continue to warm, and the moist conditions that are around are really good breeding grounds for that. The longer growing seasons that I mentioned are allowing multiple generations of insects that can build up resistance to those things. With the weed pressure, with the very moist conditions, obviously, you're seeing an increased pressure from those weeds, so farmers are having to, continually stay on top of those. So it's just an example of how, the conditions that really aren't new. These wetter conditions have been here for the last decade or two. Have really allowed some of these things to put more pressure and make things harder on farmers in general.
Yeah, I think that's a great point to bring up. And I know, my bias towards Southern Ohio, we're constantly watching what's going on in Kentucky and Tennessee to watch diseases move up into Southern Ohio. And we know that this winter we had, although it got cold during the polar vortex, it wasn't cold enough for long enough to kill off a lot of these pathogens that we have to battle with. So it's good to know from your perspective that we're going to have favorable weather conditions. It's pretty likely. And we can start thinking about how we can be ready to manage those diseases when we pull the trigger. So I just want to do a plug here. Coming up in August, you're going to be at the Southwest Ohio Corn Growers Field Day on August 13th to talk about some of the weather conditions we're seeing and how that is facilitating disease spread at that point in the summer.
Sure. Yeah, and we'll get to test how accurate my early season projections are as well, and work with the endurance on disease pressure in Ohio, and perhaps how the conditions this year have led to some of the things that perhaps you'll see as we move through the season.
Yeah, I think this is exciting because when we're talking about summers where we're seeing high levels of moisture and it's difficult to get in and make those fungicide applications, having just a couple days advance notice if we know that a storm is coming up from the south, I think could be really invaluable. And that's some things that I'm excited to learn with you, Erin.
So I have kind of an off-the-wall question, and I'm not sure if you'll be able to answer it, but we talk about like the last couple decades have been wetter than normal, and then maybe there's been decades around the Dust Bowl or something that were drier. So is there a point in time with climate that you can say, or weather, that this is the new long-term trend? Or, I mean, we have so much weather data in some cases going back so far, where say yields have been on a increased trend line for 10 years. Okay, this is the new trend line. But weather, I mean, it just changes, and we have climate change to consider.
Yeah, so when we're thinking about that question in terms of are we seeing a new normal, it's really the question, the difference between weather and climate. Obviously, weather is chaotic, right? Very rapid changes over short periods of time. And climate's a more longer term look. And given the data that we have since, the last 125 years, certainly we've entered a new normal, a long period of wetter than normal conditions with extreme precipitation events. And this isn't new. This is something that we've seen certainly over the last couple of decades. So I think it is fair to say, or fair to ask, is a year like 2018 or more like our new normal? Because we've certainly seen more of those more often than not. Mm-hmm. And so I think it's also a great way of thinking about management side of things is, given the fact that even though we know every year won't look exactly like 2018, we can make some decisions ahead of time that help sort of hedge against the fact that we know we're going to be warmer and wetter than average in general. And be prepared then for when certain situations arise or extreme precipitation events come along, to be prepared for those scenarios. And so I certainly think based on the data that we have, we can make those assumptions about sort of this new regime of wetter and warmer than average.
Yeah, that's an interesting way to think about it because, yes, we do see a lot of challenges as a result of these weather conditions, but the trade-off that we're seeing is really we're trending with higher yields because of this moisture that we're seeing throughout the summer. So, learning to manage the risk around that water can be an advantage in some cases.
Yeah, and I think too, it also speaks to the fact that a lot of times we isolate these conditions or these variables. Yes, it's wetter than average. Or yes, it's warmer than average, but all these things are operating together, right? We know, for instance, we've seen record or near record yields of corn every year since the drought in 2012 because we've had plenty of moisture. But we know that projecting into the future, that at some point those crops will pick up on the heat stress from the increase in temperatures. And so where we gain from our precip, we may lose because of stress not only from temperatures, but also insects and weeds and that sort of thing. So none of these things exist in isolation. And so management, I think, should be geared around a multivariate approach, right? Of what are the possible or potential harm or challenges, and then how do we really manage all of those in a big basket?
Yeah, and not to forget about improving soil health, reducing erosion, because you mentioned increased precipitation, intense events. So we've seen that the last couple of years. Areas that flood maybe once every 10 years, we've seen the last couple of years. And driving around, I see a lot of gullies and stuff like that. So keep that in mind as well in the off season, that we're seeing some impacts of increased soil erosion, I think, too.
Yeah, certainly. I mean, I'm not a farmer, right? And I don't have that precise expertise and experience. But if I had some advice based on where I see the projections for the future, we're going to have to deal with more water. And so we need to build resilience to that scenario to help improve the soil structure, stability, and to really minimize the erosion. I think it's really important, like you said.
All right. Well, this has been really informative. I think it gives us something to plan for this coming season and also long term. And your insight, you say you're not a farmer, but you definitely have a great understanding of agriculture, and I know you like to work closely with us and the farmers, so we appreciate that, and your passion for it really comes through. So
Thank you.
Thanks again for sitting in and providing some helpful information.
Sure. Can I offer a plug here?
Yeah.
Sure.
So at the State Climate Office of Ohio's website, climate.osu.edu, throughout the growing season, I'll provide a weekly hydroclimate assessment that you can visit and take a look at the conditions as they're changing throughout the season. So certainly encourage you to check that out and hopefully find that useful.
And also the farm website?
Yeah, so we do have a tool that's available to help farmers with nutrient and fertilizer and manure applications, giving you some precipitation forecast at field level, and be able to look up historical forecasts. That's at farm.bpcrc.osu.edu. It's the Field Application Resource Monitor with the State Climate Office as well.
Great. Well, thanks again.
Yeah.
Thanks for listening to the Agronomy and Farm Management Podcast. Join us again in 2 weeks for our next episode.